Hello, today we're going to talk about our deep learning project. We tried building a stock prediction network, so let's dive into it. Before talking about each step, I will say that every part of the way we had different ideas, approaches, architectures, but today we don't have a lot of time, so we're going to focus mainly on what actually worked. We're going to talk about the data fetching and the pre-processing, which eventually turned out as the main effort, to say the least. The second part will be talking about the model architecture and design. We'll talk about some of the interesting results and conclusions. So let's go ahead and start with the data pre-processing.
Yeah, so as Gal said, the data fetching and the processing was a major task. And we had many factors to consider, from what time frame we were looking at, global trends, which stocks we chose, how many days we look back, and so on, many, many more. And obviously, we had to verify the correctness of the data points. Let's go ahead and talk about the pre-processing. We have here a very small portion of one of the final processed data points. We have the dates and the technical parameters that were processed, normalized, scaled on different methods. We tried many different inputs, both inputs and scaling and normalization techniques, until we reached a good enough results that enabled the model to actually learn and converge. We here have below some visualization for ourselves to see that the model gets the actual data we expect it to get. And here we're going to explain shortly how the labeling of the data points was made. So we have 5 target days, and we have a metric called ATR, which measures how much a stock is volatile, so how much it moves on a certain day on average. And based on that, we look at the opening price of the target days and check if it goes up that amount or down or below it, and classify it to buy, sell, or neutral.
So at first, when we inputted only the raw stock, even if we processed it, but the raw technical data, we got networks that weren't returning good results. And we saw that when we added the extra input, the days of the week, the month, and so on, we're getting better results. And influenced by that, we wanted to add extra external signals. For example, here we tried adding weekly news or daily news for each stock, but as we can see, there's very high variance. Some stocks had even thousands of articles per day, while others didn't have any at all or had low quality ones. In the following example, we can see that the API we used, and something that happened cross APIs, returned some low quality articles. Here it returned an article about why getting rid of plastic packages is a good idea as a stock indicator, which obviously isn't correct. And I won't go over the full processing flow, but I will say that eventually we used a pre-trained FinBERT model, which is a tuned BERT model, trained especially for stock and finance-related text. And we outputted for each day and each stock we had news for, a vector that included a score for the relevance of the news that day, sentiment score, and specifically negative, positive, and neutral score, weighted average on the top articles. So we're going to go over briefly about the interesting parts of the architecture. The first block I want to talk about is the VSN. The importance of this block is that it outputs feature important weights. So it gets as input the features we chose and across different timestamps, either 20 or 50, and it gives each one of them a special weight. The second interesting part is the LSTM. This part mainly acts as the local or short to mid-term temporal processor. We wanted to give some kind of temporal meaning to days that are close to each other. And the next stage is the multi-head attention, which main idea is to catch the long-term relationship across the different time steps. We used a classifier. We also tried regression, but we eventually chose this, and some kind of cross-entropy loss function, which was weighted and edited specifically for our cause.
We compared between 2 models, one trained on the full dataset with no news and no sentiment news, and the other version is the optimal version's fine-tuned version of it over a smaller dataset with news sentiment inputs. As we see on the left-hand side, the results for the fine-tuned model over the news dataset, the loss, and on the right-hand side, we can see the comparison between the two, and we see that actually the results are worse when we fine-tune the optimal model with a news dataset. Not by a big margin, but we understand from it that our specific architecture and dataset and the news dataset, the model wasn't able to associate learnable patterns to it. And to give a context to the numbers, normally these numbers are actually considered pretty high among our results and among the online results, as the nature of the stock market is very unpredictable.
Thing is that we talked before about the sparsity of the different stocks. When we used a small data set and we inspected the first VSN model, as I said before, it weighs each feature differently. And when we looked into our better results, we saw that we're getting results of this sort, where the first important parameter is a technical parameter, it has to do with the volume. Second one has to do with the date, it's day in the month. And the third and fourth had to do with the news. The first one was the weighted relevance, and the next one was the negative result of the news in that day.
So after the results were concluded, we wanted to see what we can do with our achievements. And we attempted to check to follow a strategy of investment that fed our optimal model, the test set, And based on its predictions, whenever it said labeled a buy, triggered a buy, we checked for the highest confidence one and then followed its recommendations. And as we see here, we were able to achieve a pretty great result of actually overcoming the S&P 500 benchmark index. We can really see here that the model sees the negative trend here in the beginning of 2025 when the tariff tantrum occurred, and we stayed on cash. And then when the stock market began rising again, the model recognized that and gave us more buying triggers. So eventually, we see on the top left, we had pretty great results from it. Yeah.
So we had many conclusions, and what to do next. We're going to talk about the main points. Some of them are well known. First one is that technical data isn't enough. As we said before, when we inputted only the technical data, we didn't manage to get well-performing models, and we had to add some kind of external input. If it's days of the week, of the month, or even when we had good quality stocks, we could add the news sentiment, which brings us to the second point, which is stock market is highly influenced by external factors. We already know that. The last conclusion is that even though it's difficult, deep learning models can successfully learn temporal patterns in the very noisy stock market. We think that with further research, results can get even better. And
Yeah.
that's it.